Welcome to today's edition of SnapCast. SnapCast is the segment that dives deep into the cerebral wonders of scientific research, making complexity a bit more palatable for all of us curious minds. Right now, we're embarking on a fascinating journey through a series of papers that set the stage for the development of Sora by OpenAI, a groundbreaking text-to-video model flaunting unprecedented fidelity and consistency. It's a venture into the heart of machine intelligence. And today's feature takes us one leap closer to understanding the foundations of this innovative model. Ever pondered what goes on behind the scenes when machines learn to understand and predict video sequences? If that tickles your curiosity, you're in for a treat. We're snapping into unsupervised learning of video representations using LSTMs, penned by the brilliant minds of Nitish Srivastava, Elman Mansimov, and Ruslan Salakhutdinov from the University of Toronto, published in a prestigious journal dedicated to cutting-edge AI research. Prepare to embark on a journey exploring how a computer can teach itself to understand the visual world, a crucial step toward realizing the dream of high-fidelity, consistent text-to-video transformations. Diving in, the crux of this research lies in the ambition to enable computers to learn from video sequences without humans spoon-feeding them what to look out for. Essentially, the art of unsupervised learning using long short-term memory LSTM networks. Imagine teaching a child to recognize patterns not by showing them flashcards, but by letting them observe the world unfold. Similarly, these LSTMs, a type of recurrent neural network adept at learning sequences, are trained to ingest videos, digest their essence, and predict subsequent sequences or reconstruct what they've seen, all without explicit instructions. The methodology is as fascinating as the aim. The team employs an encoder-decoder framework embedded within the LSTM network. This sounds complex, but think of it as a two-part brain. One part encodes what it sees into a complex understanding, and the other tries to reconstruct the visuals or predict future scenes based on this understanding. And here's a kicker. They didn't just work with raw pixels, but also dabbled with higher-level representations, or percepts, gleaned from pre-trained convolutional networks, making the learning process akin to standing on the shoulders of giants. Their virtual lab bench was set with two heavyweight video datasets, the UCF-101 and HMDB-51, a playground where the model's predictions and understanding were put to the test against human actions. Imagine a machine watching endless loops of videos, learning to discern the subtleties of human movement, and you've got a good picture of the experiment's heart. Now, why does this matter? The implications are profound. In a world hungry for data yet starved of the means to label and curate it efficiently, unsupervised learning is akin to finding a well in a desert. It promises a future where machines can learn from the vast unstructured data surrounding us, opening doors to smarter AI that can perceive the world as we do, and perhaps even beyond. Wrapping up, the paper reignites the belief in the power of LSTM-based models for unsupervised learning, particularly in the context of video. The standout performer, a composite model blending the encoder-decoder's reconstructions with future predictions, hints at a future where machines not only see, but anticipate. That's a wrap on today's SnapCast, a glimpse into the sophisticated dance of algorithms that's paving the way for advancements like Sora. Stay curious and stay tuned. We'll be back with more bite-sized science breakthroughs that'll blow your mind. Until then, keep snapping into science and let your curiosity lead the way.